We are live. Thank you, folks. Thank you for joining in. If you are joining us right now, thank you for tuning in. This session probably it's gonna be very useful to those who are building agents. To give brief about what these live streams are all about, we have done live streams in the past, and we have done a couple of live stream where we talk about certain tool and start with the code demonstration, which has worked well. But this is our first live stream in 2026, and I wanted to do few things bit differently. Every one of us these days we vibe code, right? When we are vibe coding, obviously it's very hard to resist because it is very quick and easy for us to write specific code. And during this process of vibe coding, there are different issues or challenges one might face. It can be in terms of optimization, it can be in terms of productionization, or different algorithms that we are using, right? And sometimes there are also some hidden issues that we are not even explored yet, right? You just give instruction, you get the output, but what is happening behind the scenes, it is not aware, right? You are not aware of those concepts. So this live stream, the major goal is challenge and tackle, where we pick a challenge which the devs are facing, and based on that we tackle this issue in live, right? Where we bring certain experts who are building amazing frameworks for open source community, and they can share their knowledge on how people are using it, why they are using it, and what are the issues that they are tackling, right? So this is where in this session we'll be talking about AI agents, not just building AI agents. What do you do after building a AI agent, right? So this can include tracing, evals, monitoring, and other debugging issues. So let me introduce to the speaker, Claire Longo. She's a AI researcher at Comet. So today she'll walk us through Opik, which is an open source framework. So let me put my screen. Um, I've added the screen of Claire. So Opik is again a LLM framework which helps you for tracing, evaluating, and as well as monitoring your LLM pipelines. And it's not just after what you do building agents; it's within your pipeline. So I'll leave Claire to introduce herself in detail and also what this platform Opik is, and we'll also talk about OpikAssist, which is one such solution which Opik provides, which helps you to debug your AI agents and the dashboard which you are currently logging in. So without further ado, again, Claire, thank you for the interest and speaking at this event. I'll leave the screen up to you.
All right, thank you, Tarun. Hey, everyone. It's really wonderful to be here. I'm sharing some of my favorite topics today. We're talking about what to do after you build the AI agent, how to really create an AI agent that's going to scale in production and have that full observability strategy. So Tarun and I have been collaborating the past using Opik, talking a lot about projects and where Opik fits in. And we thought this would be a really good topic to highlight what Opik does. So let's dive in. First, what is Opik? Opik is an end-to-end model evaluation platform. It provides tracing. It's a framework for creating LLM evals. And it also will take you a step further from just looking under the hood of your model and tracking everything that's going on. It takes it a step further towards optimization. So you can start doing things like optimizing the prompt, things like that. So it's this full end-to-end suite of tools. It's completely open source. It's free. I think Tarun will drop a link in the chat so you guys can all access it. But it's free, and you can get started with it today as it's an open source tool, as well as contribute. I love getting people involved in the open source community and contributing so we can all build together. I've learned throughout my career that the best way to learn a new tool is to just build with it. And I personally have to stay on top of everything that's going on with Opik. We're releasing new features all the time. So I'm constantly building new Gen AI applications. For the purpose of illustrating the concepts I want to walk through today, I actually built my own Gen AI application. It only took me a day because there's so many amazing tools out here. But I want to walk you through what this tool does and talk about the different tech stack I'm using across it. And then I'll show you how Opik plugs into every phase of the life cycle here, really taking this AI agent to like the next step of production ready. So it's a really simple application. It is using multimodal data in the Gen AI context. It allows the user to just enter an animal and location, and it's going to do some research about the animal, and then use the Sora 2 model from OpenAI to generate a video with narration. So I thought this would be a really cool tool to use if you're just maybe traveling, you want to learn about the local wildlife, or maybe it's useful for children who are learning in the classroom, but it's creating a really interactive video so that the user can really iterate with it, learn more about different kinds of animals, and get a video as the output. The reason I put this project together is it's a good example of how we can very quickly create useful AI tools, but it's also a good example of using different data types. I have in this architecture here, you'll see there's a research agent, and that's a purely text-based agent that's going out and putting together all the accurate facts about the local wildlife. And then I have a video agent, and that's the call to the Sora 2 model that's taking the facts, turning it into audio narration, as well as generating an actual video. So there's 3 types of data here. We have audio, we have video, and we have text. And when you have these more complex agents that are multimodal, and in a multi-agent framework, I have multiple agents here as well, it becomes a little bit complex to measure how they're performing or pinpoint where they're breaking if we're trying to debug them. So what I'm going to be talking about today is how I layered in an observability strategy on top of this architecture using Opik. And I'll show you how I created an evaluation strategy, what kind of metrics I layered in here for monitoring. And then I'm also going to show you an AI-assisted debugging approach for when something does go wrong. And also, if you have any questions, I think drop them in the chat too, and we'll make sure we address them. Awesome. So the first thing I want to point out is the different phases of this project. Phase 1, I'm in research and development. This is where I'm doing things like iterating on the prompts. I'm iterating on the agent architecture like I showed in the earlier slide. I'm choosing which model I'm going to use. I might be tweaking the parameters of the model itself. And I'm debugging things. There are a few like calls that just broke, they didn't work. I had like the wrong data format in my pipeline at one point, things like that. So I'm in this kind of iterative phase, and nothing is live yet. Then once I feel like I have a really good application, I want to host it live and give my customers access to it. That's where things like continuous monitoring, I need customized dashboards to view the metrics I care about, as well as I need the ability to collect feedback from my users. So if they do run into issues or they do really like the output, that I'm actually collecting that information so I can keep improving my application over time. So these are the 2 distinct phases. In some past projects, I've had different tools across these different phases, and I've learned that that's not actually ideal. If I'm doing things like creating evaluation metrics, running benchmarks in the research and development phase, I want to be able to access those same exact metrics, maybe even leverage the same code in the production phase. And that's what Opik really helps us with, is it comes with us across every phase of the project, solving both pre-production and production issues. I'm going to show some code pretty quickly here, but let me first walk you through the kind of puzzle pieces of Opik that we'll be using here.
Is it possible to do full screen? These slides to have full screen?
Yeah, let me see. I might lose view of you guys. How does that look?
Yeah, this looks perfect.
That looks great. Okay, yeah, just interrupt me because I can't see the other screen now if there's any questions. Great.
Cool. Yeah.
Thank you. Okay, so the first feature we're going to be working with is prompt management. I use this in Opik in the early phase of a project where I'm just iterating on the prompt. In this example, I started with a very simple prompt, and then that prompt, I iterated a few times to make it much more complex and specific. But the prompt playground in Opik is just a really great tool to do that iteration, as well as save versions of your prompts so you can track what worked, what didn't over time, and know exactly what version of prompt you're using in production. The other tool is tracing. This is kind of the backbone of everything we'll be talking about. Tracing logs all the inputs and outputs. You can see here, my application has a lot of steps in it. So one trace includes multiple spans. I have the research agent, I have the video agent, each one has a few steps, and then I have the agent orchestrator, which I'll show in my code how that comes together, which is a function that really ensembles everything together. The value of tracing is there's multiple values here. One is just the ability to debug. I can see all the inputs and outputs. So if anything breaks on this path through my agent, I'm going to be able to see exactly where it broke. I'm also tracing all the inputs and outputs. I can trace audio, video, as well as text. So I can see the prompt. I can see the video that was the result of the prompt. And that's going to be very helpful in a debugging context, as well as just general evaluation. I can put metrics across these traces to measure how things are going at scale. And that takes me to evals. So I'm always curious if people in the audience are familiar with LLM as a judge eval metrics. LLM as a judge is the concept of using an LLM to judge the output of your LLM. So you're using two LLMs here. I already have my LLM agent system that's producing the output. It produces the video as well as the text narration. And what I'm doing here is I'm using another LLM to just evaluate that output and cast the evaluation into a metric. The reason I love LLM as a judge metrics is it gives me a way to measure some stuff that I maybe was not able to measure directly in the past. Things like hallucination. One of the eval topics I put on this project is topic. I want my users to stay on topic. I don't want them to use this application for anything else outside of the intended purpose. So I actually have an evaluation metric that's checking if the user input is related to wildlife topic. So that gives me the ability to actually have a metric that I can monitor over time for something that maybe was difficult to measure directly in the pre-LLM world. So having this being an LLM actually gives us a lot of power for customization. I'll show you in the demo how I set up these metrics. And last of all is monitoring. So I showed the puzzle pieces with prompt management, evals, tracing, and finally, monitoring is kind of the icing on the cake here. Once the application is live, we want to be able to keep track of our evals at scale and collect all our traces for every interaction our users have. Previously in the research and development phase, we were using those tools to debug, maybe to run experiments, compare different prompts using the eval metrics. And now I can use those same tools to create a sophisticated monitoring strategy. I'll show in the demo how I created a custom dashboard, but essentially what you want to do in this phase is you want to monitor the metrics that are most important to you. I'm going to be monitoring my eval metrics as well as key metrics around cost, latency, and things like that, so I can keep an eye on the performance and get alerted more proactively if something goes wrong. Let's jump into the demo.
So before we go to the demo, we have two questions that we can probably pick it up. So the first question is, how do we know an agent is actually ready for production, and what checklist do we need to follow before shipping?
Yeah, good question. Gosh, I'm having So how can you ask it again? It's about knowing if it's ready for production.
Right, I've added it on the screen. It says, how do you know an agent is actually ready for production, and what checklist do we need to follow before shipping?
Great question. Okay, so there is a checklist here. So an agent is ready for production when it's kind of past a set of tests that we've set up for it that define that. There's some simple things like maybe there's a certain cost that you don't want to exceed when it goes live. So having that estimate of like how much is this going to cost to estimate, to how much is this going to cost to run, how many users do I expect to use it when it goes live, just having kind of an idea of what that looks like, I think is always important. And then the other kind of category is quality. So typically the quality itself, like there's some general metrics you can look at. Like I always look at hallucinations. I always look at fairness and bias things when it's related to like an LLM. But then some of the metrics are going to be more personalized to your use case, which I'll show today. Like I really cared about video quality. I think in other applications that don't have video, it doesn't matter. There were certain aspects of the video quality I cared about for this application. I wanted it to be realistic. And so I did come up with some very like specific metrics that I wanted to reach a certain threshold before I felt like it was ready to go. But the tip I would give on this is like, it is a pretty iterative process. I think the key is like having those set of metrics so you have the ability to measure how good this app is performing and then continuing to measure those in production. Almost every application I've seen, like we learn something when it goes to production and then we have to go back and improve it. You just don't want it to be like a really terrible thing. So there's this checklist that we want to go through in terms like cost, quality, latency, those three categories.
Right. We have one more question. Do Opik provide LLM as a judge for custom metrics?
Yeah. So the LLM as a judge is a custom metric. So That's a really good question. We have some pre-built LLM as a judge metrics. Like we have one that's pre-built for hallucination. So you can just use that out of the box. And then we have a framework where you can create your own custom LLM as a judge. You can do it programmatically and you can do it in the UI. So I'll actually show that today. And I think it's one of the most powerful capabilities of Opik.
Right. We'll take one last question before we proceed with the demo. If the agent finishes the task, but the output quality becomes garbage or irrelevant, how do you detect and alert on that?
Yep, really good questions. You guys are leading me right into the demo. I love it. You're going to want to use the eval metrics to do that, and I will show you exactly like where to place them on the traces to accomplish that.
Right. And also, just to give a short intro, like we recently had a live session and as well as a video where I detailed out how you can build your evals pipeline as well. Where actually I used Opik. I mean, for tracing and evals, I had used Opik. But for the evals that we created, first you generate the data set, and this data set is something that has to be evaluated by your domain expert. So let's suppose you have a use case, and once you have the use case, you have specific client or you have specific head who knows what the data is about, who knows the user journey. Like if I'm your end product, if I'm your end user, what kind of questions will I ask? So if you have that understanding, probably you can start with generating the data sets. And
Mm.
Opik again provides you to monitor different version of the data sets. And in order to generate data set, again, there are different parameters to tackle multi-op, single op. So this is what I had shared it in my previous video where we used ragas. So probably after this session, you can check that out. So you'll get more clarity. And we have versioning of data set as well. So probably Claire can take more in detail what the demo is mainly about.
Yeah, that's a good point. The data sets is one of the really powerful features in Opik. I didn't use it in this demo, so that actually works really well with your video as well, because that would be kind of a next topic to learn there.
Right. I have covered that. So yeah, so this
Fantastic.
is something that they can continue after this session. But yeah, we can proceed.
Awesome. Okay, so we're looking at my code here. The code for this agent is actually quite simple. But let me walk you through what I'm doing here, and I'll zoom in a little.
Is it possible to zoom the screen
Yeah, how does that look?
a bit more? Just one more zoom. Yeah, this looks perfect. Yeah.
Okay. Yeah, I know it looks different on the YouTube screen. Okay, so here's what I'm doing here. I'm setting up Opik. It's a simple pip install. This is an open source repo. And then I'm configuring it. This is simple. This is where you're setting up your project workspace, API key. And then I'm using OpenAI. We have a ton of integrations with all kinds of different LLM providers. So if you're using like the Google ADK, OpenAI ADK, whatever tool you're using, we have coverage for almost every single integration you could imagine, and we're always building more. This is really powerful because it means that I don't have to rewrite my code to layer in Opik. If I had already written my agent in OpenAI using their API, to get a solid observability strategy, I don't want to have to go refactor my code or change my provider for the model or anything like that. So we have a lot of coverage across these different providers for integrations, and it allows you to integrate Opik with just a few lines of code. So let's see what that looks like. Here is my research agent. So the research agent is just a function. It's a very simple prompt. It's telling it to generate a few one-sentence facts about a certain animal in a certain location. And it's just using GPT 4.1 mini. So very simple call to the OpenAI SDK. The thing I want to point here is this @track decorator. So that's the Opik integration. It's that simple. And this track decorator, after importing and setting up the OpenAI integration with Opik, this track decorator is going to automatically track anytime there's a call to this function, and that becomes part of the trace that we'll see in the UI. So as long as my code is organized really clean like this, the integration with Opik is going to be very simple and reflect that kind of organization in the traces. The next agent is the video agent. So this agent is using Sora 2. If I were to iterate more on this, I think I would mess around with changing this model a little bit, changing different versions or parameters on it. Because that's something I saw really impact the quality. But again, it's a simple agent. It's taking the prompt. It also takes the, let's see, it's just taking it's just doing the video generation. And then the orchestrator is where it all comes together. So again, I have the track decorator on this one as well. So the orchestrator is just a function. It's calling both agents and kind of ensembling the results together. So I'm generating the facts here. Here I have the video prompt. Then that goes into the video agent generator. It just accepts the prompt, and the facts are now part of the prompt. And then this is the output. Pretty simple. I have metadata on the animal, location, I'm tracking the facts, and then the final result is the video. So when I run this, it's really simple. It does have a bit of a latency problem because I made this in one day, so I'm not going to make you guys wait while I generate this. So I went ahead and generated one ahead of time. So all the user has to do is enter the location, choose their favorite animal, and this is what the output looks like. And the cool thing you'll see here is because I have those track decorators, Opik is automatically going to log everything, and they gave me a link to tell me exactly where to go in the Opik UI to see what this looks like. So let's go take a look at the output. All right, so I'm in my Opik project. Let's zoom in a little bit again. What you're seeing here is each line is a trace through the system, and the trace contains spans. So let's click on the most recent one. It's very interactive, so I can really dig into these traces. But first I want to point out the structure of them. So we have the agent orchestrator, which is really kind of that wrapper putting together both agents to produce the final output. Within the agent orchestrator, we have the research agent that's generating the facts. That's a call to the GPT-4 mini. And I can see the inputs and outputs here. So I can see the facts that were generated. And one of the most valuable things as well is I also have a cost estimate. We're able to estimate how much a call like this costs through OpenAI API. So now as I'm debugging and also when I move this to production, without having to really code anything up, I have an estimate of the cost for running my application. Then we have the video agent, and we can actually log the video inputs and outputs. So this is pretty cool here. We can actually see the video that was generated, and that's attached to the trace. This is going to be really helpful in a debugging environment where maybe I'm trying to figure out how to change the Sora model parameters to get a higher quality video. Maybe one thing that stood out to me actually when I went in here and looked at these is that some of the audio narration sounded really robotic. And so that helped me go back to my prompt and tell it like what kind of voice I wanted to hear in the narration. So this helps me spot check things. I can also go to Tarun's other video and learn about the data sets. I could also like curate like a benchmark data set of maybe like 100 different examples and test things more at scale instead of spot checking. So you can use this same framework to do like some more like scientific experimentation as well. Let's take a look at the video. Okay, so you can see like the audio is terrible. I don't know if that came through. And the movement is a little choppy. So it's kind of close to the quality that I want, but it's got some improvements that we need there. So that is where the feedback scores come in. So these are the LLM as a judge metrics. I can always spot check my input and output, but that is not going to help me get an idea of just how well my system is working overall. It's not as reliable as just having a metric that I can actually measure to say like, hey, my quality is on average 7.5 and I need to increase that. So that's what we're getting here. I have two eval metrics. The first one is topic. This is an example of like a general kind of metric you want to put on these systems all the time. I typically have like topic, fairness, bias, hallucination on almost every application I build. So that's more of a simple one. It's just looking at the input to make sure it's staying on topic. The really personalized one here is the quality. So the quality is measuring the quality of the video on a scale of 1 to 10, and it's giving me an explanation. So it did detect like the kind of scene stability issues. There was kind of some jerky motion. So that is really useful when I'm trying to debug. So let me show you how I set up those scores. If you go here to online evaluation, this is where I configured both these LLM as a judge metrics. Let's take a look at the quality one, and I'll show you what it looks like. So these metrics can be placed at the trace or span level. So going back to the earlier question of like, if the output's still produced, but it's not good, like how do you measure that? This would be a really good example. You could put an eval metric like on an exact span. So even if like that span succeeds technically, if the output is garbage, then we could actually use a, LM evaluation metric to detect that. This is what it looks like. So I can choose the model type. I have OpenAI connected here, so I can go with any OpenAI model, but you can connect to a lot of different providers. And I have a system prompt that's really just giving it its personality. It's a expert in detecting quality issues in videos. And then I have the user prompt. And this is where I could get really specific, and I iterated on this a bit. It's very powerful because I'm able to customize exactly what I'm measuring for and kind of align that to my use case. So in this example, I really cared about visual coherence. We saw an issue with that. Like there's kind of like some weird movements of the bird, things like that. So it just didn't look very realistic. I want to keep things like looking very real, so I can spell that out very directly. I want it to be like cinematic quality. So I was able to get really specific here. Whatever you want this output to look like, this is where you can start kind of putting that into the element as a judge evaluation metric, so you can actually measure if it's staying aligned with what's in your prompt. You can define the scoring guide yourself. I am often using binary labels, just like 0, 1, yes, no. But in this case, I thought I'd give an example of just putting it on a scale from 0 to 10. So the video we just saw generated is falling in here. It's high quality, but it's got some minor issues. So all you have to do is configure this, save it, and then every trace, every call that the user makes through your application, every trace will be logged here. So you have not only the traces, so you can see all the inputs and outputs, but you also have these LM as a judge metric. So you can see generally the patterns in them over time. So the other piece is the debugging. So let's click into one where we see an error. So a lot of these calls are looking great. They're giving us good output. This one didn't look so good. So let's click into this trace and see what's going on here. This came through when I was tinkering with changing some of the code around the agents. And I'm seeing an error on every span. Everything's logged here, so I can see the actual Python output from the code. But digging through this and trying to figure out what's going on might be somewhat tedious. So that's why we added debug with AI. And I'm going to just prompt it here. Tell me what is wrong and how I can improve this. So you can ask it very specific questions, and it's going to use AI to actually review your traces and interpret it for you. I find this really useful in like the research and development phase where I'm debugging stuff. So what we're seeing here, I think it was a data type issue, parameter matching. Yep. So it quickly, this was it. I remember it when I was debugging. So there was a object that was not JSON serializable when it was expected to be. So it helped me like very quickly debug what was going on in this trace. This is a good example of just identifying how I can improve the app from a code perspective, but it could also be something that's breaking from like the evaluation perspective. So maybe if you're still getting an output, but it doesn't look right, let's ask it. How can I improve the quality of the output? Oops. So this is an example, the one we looked at before, where it did produce a video. But I think we could make this application better. Let's see what AI says. It's organizing things into actionable insights. Okay, I like this. So this is really helping me iterate. It'll probably help me like improve the original prompt, but this is what it's defining as like actionable insights, scope and constraint. So the instructions are well constrained. So it likes that how specific I am in the prompt. That's good. Fat consistency. There's strong risk. There's strong end-to-end coherence and minimal risk of hallucinations. Okay, again, I think that's because I made the prompt very specific. Yeah, so it's looking like pretty good because it's a basic app. But essentially, it looks like I can really improve this by adding explicit checks or source validations and enhancing the richness of facts in the prompt. That's something I didn't think of. And automated feedback. Okay, so it's giving me kind of like the next steps. It sounds like it likes my app. It's pretty clean, but maybe too simple. And that's really helpful. This is, I feel like this is like an AI brainstorm buddy that's going to help me build something better. So I want to show you guys an example of that. Let's hop back to the project. The last thing I want to show is the dashboard. So we talked about all the evaluation metrics I set up. Once the application is live, I need like a single snapshot to go look and just see how my app is performing at scale across many users. And that's what this does for me. So you can see here, I've got the eval metrics that we created, the quality and the topic. If there was high volume coming through my application and anything went wrong, we would see one of these spike as an outlier, and that would indicate that I need to go debug something. I could use the OpikAssist debugging agent to help with that. I've also got estimate of cost, all the typical things you need. Going back to the question about like what's like the checklist when something's ready for production, this dashboard is kind of my checklist. I've got cost and usage categories. So I'm looking at number of traces, estimated cost, which we're getting from Opik. So the cost category is covered here. I also have duration and latency. This is an area of improvement. It takes a while to generate a video. So keeping an eye on this really helps me keep an eye on the user experience. If they're waiting forever for their output to generate, they might become frustrated, they might disengage. So that is the other category I really want to cover. And the last category is the top one here with the kind of specialized evaluation metrics. In this case, I care about these ones. So these again are like the metrics that I'm going to want to be monitoring in production. I think that covers everything I wanted to show in the demo. So I will pass it over to Tarun to see if there's any questions.
All right. So we have one question. I'll just add it here. So apart of OpenAI, does Opik support any restriction on tracing on any LLM, or can I directly use track decorator?
Oh yeah, great question. So we have we do both. So you can trace any LM with the track decorator, and that gives you the ability to really customize like exactly how you want it traced, because you're structuring your code with different functions, and then where you layer in that track decorator defines what the structure of the trace looks like. So that's possible with like any LM. The OpenAI one is an example of an automatic integration of which you have very, very good coverage across a lot of different providers. And you can use them together. So a lot of my applications look like I'm generally using like one of the integrations, but then I might have some other specific logic and functions around it that isn't part of the OpenAI SDK. So then I'm also using the track decorator to add to that trace as well.
So we'll take one last question before I summarize. So the media like videos, is it stored as artifact or is it automatically traced? Can you show that part?
Yeah, so it's automatically traced. And you can also store it as an artifact. That's a really intuitive question because I feel like you're probably looking at how I did this and notice that. So the one that I'm showing right now is an automatic Sora integration. So if we go back and look at my code, right here, it's just the track decorator on the video agent that is making sure everything gets logged. And then there's also some logic here that is making sure that the video gets tracked. So it's like right here. So it's like writing it to a file and then uploading it directly to Opik. We also have the ability to like add multimodal like attachments to your spans. So if you had something that wasn't like directly coming out of Sora and being this easy to track with this integration, you could still take the video content and just upload it as kind of an attachment to your trace that already exists.
Cool. I don't see any other questions, but just to summarize, I've also attached a documentation URL. So if someone is interested in learning about evals, right? So there are some evaluations which are already defined in Opik, which you can directly import. And once you import, you can directly instantiate it. And in most of the details, you might have also seen the collab notebook which Claire had shared. You just have to use track decorator, and inside that, you just have to define your LLM component. So once it returns anything, it is automatically logged in your Opik dashboard, and every details in the sense you have latency, then you have the number of tokens that you have utilized, because whenever you are building your application, not just output tokens are utilized, you also have input tokens, which at the end of the day will add it in your cost, right? So you have both input tokens and output tokens which is traced, which is very important. And apart from this, you have data set which you can version it as well. So most of the time what happens, I write a prompt and that prompt is not working, you will have a different prompt. You have to create a version of every single prompts that you're using, right? And it's not on user prompt, it's basically happening on system prompt. So that is what you're supposed to log, and I've written an article on it, which I'll be publishing it shortly. And all the URLs that you saw just now, whether regarding evals, then how to use data set management, that how you are versioning it, then how you version prompts, everything will be traced, everything will be monitored, so that in at the last, when you see your dashboard of the latency and what are the things that are going wrong, you can easily trace it, right? And most of the time what happens, when you see the dashboard, if you are not able to come up with any intuition, that's where OpikAssist comes into the place. You just have to click on OpikAssist. It is your AI chatbot, AI buddy. It has multiple tools which it will take information from your dashboard, take that as a context, and then generate the results for you. So yeah, this was mainly about it. And it's very simple library to use, and I've already created 3 to 4 videos on it. So if anyone is interested, do check out the resource link in the description. And this is the GitHub URL. Go start the GitHub repo. It's probably one of the best observability tool, what you call observability tool package for AI agents. And I've used it a lot as well. We'll have more articles and videos on it. And if anyone has any questions, you can directly reach out to Claire. She's available on LinkedIn. She'll probably be happy to help you out in that. Do you
Always.
have closing thoughts before we can wind up?
No, just thanks for having me on. It was really great to talk through these topics, and I hope it was a helpful learning experience for everyone.
Yeah, this was it from the first video. Second video is already live. We'll be doing the second live session on 11th of February. It is related to AI memory and how you can use knowledge graphs at scale, because you use both knowledge graph and as well as a vector database, which is a retrieval system. Combination of both is used across multiple memory-based frameworks that you're seeing. So that is what we'll be doing in the next live stream. So stay tuned. We'll be coming up with more such live stream, which is gonna help you in challenge and tackle series. Meanwhile, thank you again.
Thank you, everyone.
I'll just end the stream.